Well, now we need to talk about how to graph our log functions. Just like with an exponential function, which has two ways you can represent it depending upon what the base is, we have two ways to represent our log function, again, depending on what the base a is. So I have this function here on the left-hand side. This is a log function. This is y equals log base a of x. It's considered an increasing function because we are rising from the left to the right. And this is a picture when the base a is greater than 1. Notice that I have a vertical asymptote here occurring at when x is equal to 0. I'm going to cross the x-axis at 1, 0. And these are the characteristics of my a greater than 1 log function. Here on the right picture we have a decreasing function. This is when a is between 0 and 1. So we still cross at 1, 0. We still have a vertical asymptote at x is equal to 0. It's just this is decreasing. The domain and the range of my log functions, no matter what the picture is, no matter what a is going to be, the domain is going to be from 0 to infinity, and that's because we have now this vertical asymptote here at x is equal to 0. And remember, the domain is about my possible x values, so I am going to take only x values that are greater than 0 and on to infinity. And then the range, which is talking about my y values, that's between negative and positive infinity. We want to point out also that this function is 1 to 1, which we kind of know already since it is the inverse of our exponential function. So let's practice graphing. Oh, but before we do that, we want to talk about one special thing you may have noticed on your calculator, and we want to talk about also how we denote special logs. So we have two special logs that have different notation from the rest of our log system. The first is what we call the natural logs. Natural logs are log base e to x. So when I have a base e, it is considered a natural log, and we represent it by ln of x. So anytime you see an abbreviation that looks like this, ln, that's really talking about a log base e, and we call it the natural log. On your graphing calculator, you may have noticed, or may not, but you might now, there is a button. It's the ln button. And when you look at the ln button, above it you'll see e raised to the x power. And that's because e to the x is the natural log, is talking about the natural log of a function. The next type of special log we have is what's called the common logs. Common logs are when I have a log base 10. And it's common because our number system is a base 10 number system. So we abbreviate the common logs as logx. So when you do not see a base written here, then it is understood to be the common log or log base 10. Again, on your calculator, if you look at the log button, you'll see that above it a 10 raised to the x power. So those are two special logs that we end up using in when we're talking about logs. Now, how do I graph my log function? It's about as easy as it was when we did our exponential functions. There's not a lot to it, but let's go ahead and practice this one example right here. And we're going to do it using translations like we did in exponential functions. So I have a log base 5 of x minus 2. First, we want to identify what my base a is, because remember that tells me whether my function is increasing or decreasing. So my base a is 5, which is obviously greater than 1, so this is an increasing function. I know that I have an asymptote occurring at x is equal to 0, and I have an x-intercept at 1, 0. Those are the known pieces of information before I ever shift this function around. Now, what effect does x minus 2 have on my function? Remember, this is inside of the function, so it is going to shift horizontally. It's going to shift my function to the right by 2. So let's go ahead and let's graph this function. I'm going to quickly sketch a graph here, mark off a couple of things, that's 4, and so forth. Okay, now I know that I had a vertical asymptote. I'm going to start with that. I had a vertical asymptote at x is equal to 0, and I am going to shift that asymptote to the right by 2. So I'm going to redraw my asymptote here, crossing the x-axis at x is equal to 2. Remember, vertical asymptotes are denoted by the equation x equals 2. And I had a x-intercept at 1, 0, but it is now shifted to the right by 2, so 1, 2, meaning that my function is going to cross here, and it's increasing, and so that's about all I really have to do. And that's how we're going to graph our log functions.